Hello everybody, Caveman Math here, back with another video. Today I will be providing a comprehensive review of dividing polynomials, identifying polynomials, graphing polynomials, finding axis of symmetry, vertex, x-intercepts, as well as finding whether or not something like this is a factor or not with a remainder of 0 like that, factoring, as well as synthetic division, long division, and behavior, and as you can see, graphing with polynomials, and writing from the data given. So let us start with the first one. This is actually from my quiz review, so I'm just going to be resolving it. All right, so let's identify whether or not why these are polynomials and why some aren't. So this one I can instantly check off as a polynomial because there are no irregularities, like there are no -1 to the power of -1 anywhere. There's no root of 5, and there's no x in the denominator. All of these factors basically mean that it is not a polynomial. So this one is a polynomial. This one is not, because of negative power. And this one is not because radical. And this one is not because x in denominator. Right? And when that happens, you can generally just exit out as not a polynomial. Now here it says, what is the remainder when this is divided by this? Okay, since we have x plus 1, right? It says 2x that, and then divided by x plus 1. Since it's just x plus 1 and it's not like 2x plus 1, 3x plus 1, and it doesn't have a coefficient in front of the x, you can preferably use synthetic division to solve this since it's the easiest. Let's get straight into it. So we have here 2, the number. We have -3, a number. We're looking at the coefficients here. This is the 1 as x, and this is -2 as 2x, and this is 3. Right, and what that gives us is our base preliminary data. So we'll bring this little factor looking thing as the divisor, and I think it's divisor, yeah, but this would be -1, right? And then 2 would actually just come down, so we would actually be like, we actually solve it like this: 2 times -1 that we just have. So what that would give us is -2, right? And here we do the operation, which is evidently plus. So -3 plus -2, that would just be -5. And again, we're going to multiply the answer by the divisor. So it's -5 times -1, and that's just +5. So just +5. And then now we just 5 plus 1, which is just 6. And now you have to again multiply it by the divisor. So 6 times -1, -6. And then negative. So 6, 7, 8. That is -8. And -8 times 1 is, 9. Not 9, sorry, +8. Oh my god, I just froze on that one. But yeah, and that is about it. Yeah, so our remainder would actually be 8, 9, 10, 11. So since our remainder is 11, we would actually write this whole equation like this. This is not a factor. So this, first off, let's just get this straight. Not factor, because it does not have a remainder of 0, right? And now we have to just write it like this, right? So it says 2x, but it's 1 less. It's 1 placeholder less. So it's 1 power less. So sorry. So x is actually 2x to the power of 3 instead of 2x to the power of 4. And it's -5x to the power of 2 instead of 3. And it's +6 x instead of x squared, so it would just go on and on, so negative 8, and then it would be positive 11 over the divisor, so x plus 1, the full thing. This would be the final answer for this, right? But the remainder is actually just 11. Remainder, there we go. All right, let's start by finding the axis of symmetry, vertex, and x-intercepts. So first off, axis of symmetry is a part of the vertex because it's the x value of the vertex. So what we're going to do is we're going to look at our vertex axis of symmetry formula. So it's just b, negative b over 2a equals axis of symmetry. And we plug in 8, and it's just negative 8 over 2 negative 1 times, so 2 times negative 1, negative 2. And negative 8 divided by negative 2, well, you already know it is 4. So when we write it 4, now we have our first part for the axis of symmetry. It's 4, our x value. Now we're going to do the formula for the y value, which is actually just this. It's y minus b squared over 4a. That is the formula for the y-intercept of the vertex. And what you do here is you plug in, well, the y, negative 12, negative, and b, which is 8. So it's 8 over 4, and then negative 1, which is our a. So that just goes out, and this becomes, I believe, positive 2. Yes, so the whole thing is positive. So negative 12, positive 2. Well, you already know it's just negative 10. Let's check. So I actually messed up big time, because negative 12 minus 8 squared is 64. So 8 times 8 is 64. 64 over 4 times negative 1. 4 times negative 1 is negative 4. So negative, negative, positive. So that is negative 12, right? Negative 12, and then that's just positive 64 divided by 4. Brain not work. Oh my god. We got that 16. Yes, 16. And then that it goes out. So 4, big boy. 4 and 4, very big man. And now all we have to do is find our x-intercepts. So to do that, first I'm going to factor out a negative, so we can write this properly without having any mistakes. 8x plus 12, I believe. And then, okay, now what do? We do the guess and check method. So x, and then what's 12 going to, and what does 12 going to, so for it to become 8, 6, 7, 8. So we could use 6, so negative 6. Actually no, yeah, negative, wait, because negative 6, that was still okay, that makes sense. So negative 6 and negative 2, because we need the minuses to become positive, so both of these should be negative. Yeah, and now all we have to do is just put them down. So x equals 6 and 2. That is correct. So our AOS is 4, and our x-intercepts are this, and our vertex is this. Wow, very nice. Let's do the same thing with this one. All right, let's identify the variables. So we have a negative, and then we have a negative 8 over 2a, so 2. So this would just be, yeah, it's just positive 8 over negative 4. And positive 8 over, you already know, is negative 2. So our axis of symmetry is -2. So AOS, and it's also the first x value of our vertex. And now with this information, we're going to go ahead and do nothing with it. So 64 minus, what is, minus b squared. So -8 squared over 4 -2. Right, now what that does is this is 64 over -8 -64. Now, well, 8 times, because it's 8 times 8, right? And 8 times 8 is 64, so big brain move, so it's positive 8 64. Very nice. Big boy 72, so 272, that is -2 and 7, that's a crooked parentheses, that is -2 and that. Let me double check my source to make sure it is correct, because checking always good. Yes, it is indeed correct, -2. And let's move on to the next one. Given that the remainder is 0, what is the value of p? Right, now this is a very tricky one, and I will show you in a minute. It can be very easy. Let's get right into it. The first thing you need to do when you approach this is to know what you need to plug in to isolate p. Your goal here is to isolate p because it wants p, right? So you're going to write down what you have, which is all of that. 4 minus x to the power of 3 minus 3x squared plus x minus p. Essentially, what you have to do here is you're going to write the x value for this. So x minus 2 is actually x equals 2. So now with this information, you're going to plug the x value into all of these x's. So 2 times 2 to the power of 4 minus, oh, that's a bad, okay, minus 2 to the power of 3 minus 3 times 2 to the power of 2 plus 2 minus p. All right, now what we have to do is just, solve it. So very nice. 8 minus 2 to the power of 4, 2 times 2, 8, 2 times 2, 4, 2 times, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 minus 8, and let's pair the next ones. We got 4, and then we got 4 times -3. All right, next one, plus 2. This is -12, this, and then we still got the rest to do. 2 minus p minus 8, 32. Oh my god, my brain. Okay, yes, essentially all of this is simplified into 14 equals to p. We have our answer. Very nice, because we brought p to the other side, so it's not negative. All right, factoring. I will get back to this because my brain completely hanged during the exam. I will come back to this very shortly. Let us go to the divide method. So divide in best method. Okay, write your denominator in proper form. So I believe that the best method to divide this would be to either synthetic or long. There's really only two ways you could do this. Honestly, I know all of us are very lazy, so let's do it the easy way. easy way would be to do it synthetic style. So a negative 5, that would become 5, just 5. Oh, my edits are not on. Alright, that would just become 5. Now when you draw 5, it would be a squared. There is no a here, if you know, so we need a placeholder. So here is another, so it's another a, so it's, sorry, another 1. So 1, 1, so 1, 0, yeah, 1, 0, and then negative 28. Because we need a placeholder, there is no spot for an a. There's a spot for an a squared, but not an a on itself. So no a to the power 1, only a squared. So therefore we need to put a placeholder in place of that to fill it in. We bring our 1 down. 1 times 5 is 5. 5 plus 0, 5. 5 times 5, 25. 28 minus 25. 3. So 3, negative 3. Alright, we have our answers. X, yes, plus 5, minus 3 over a minus 5. This is actually a, sorry, my bad. A minus 5. That should be the answer to this. Let me double check. Yes, this turned out to be the correct way to solve this. I have checked my work and it is right. Let's go to the next one. Divide using the best method. Ho ho ho. We have encountered a big boy polynomial. This is a long division polynomial, and these are typically very complicated to solve because you have to keep track of everything. You have to make sure that everything is in line and you're not making any mistakes, because if you make a mistake any way through this equation, it will cost you a lot of time on any exam, on any homework. It's just a pain in general. So let's get it right the first time. Let's do it right. So first you write the equation. 5, there we go. So negative 16x to the power of 3. We need placeholders for this once again. Plus 0x squared plus we still have to put a 0x and then a negative 20. Let's go. All right, that's very long, as you can see. Let's get started. So what do we have to multiply to this divisor that it will become 6x to the power of 5 minus 16x to the power of 3? Well, in my brain, I can think 3x to the power of 4. And what that gives us is 6x to the power of 5 minus 12x to the power of 4. And what that gives us is, as you can see, oh, that's too long of a line, 12x to the power of, 12x to what? Wait, okay, that's crazy. Yeah. Wait, no it doesn't. Wait, okay, I'm kind of... Oh, there's no placeholder for this. Oh my god, it went to camera. There's no placeholder for this. See, I already messed up because I did not follow the right one. So right here, I already messed up by not recognizing the placeholder in between 6x to the power of 5 and negative 16x to the power of 3. And that's 4. Wow, I really messed up on that. So now we're going to fix it. And we're going to do negative, because that's a negative. There's always negative here. That would be positive 12x to the power of 4. And what that basically gives us is 12x to the power of 4 and minus 16x to the power of 3, because that comes down, right? So we got that. We got that down in the bag. Now what we need to do is find another one that multiplies to this that will cancel out this until we get to a remainder. Now let's get it started. I can think of 6x to the power of 3, and if we plug this into the, like if we not plug in, sorry, if we multiply 6x to the power of 3 to 2x minus 4, you get this abomination, negative 12x to the power of 4 plus 24, 3. Okay, now let's go to the next part, which is subtracting them. Let's get it. 8x to the power of 3. Now we have 8x to the power of 3. Now this comes down. We have our remainder. No, not our remainder, sorry. Our placeholder. And it comes down. And then when that comes down, well, you already know. We need to find another thing that multiplies. 4x to the power of 2. Now when that multiplies, it's just 8x to the power 3 minus 16x to the power of 2. All right. Now we already know we have to give this thing a negative, so that would turn this positive. Well, you already know we got all of that, and this minus is down, not minuses, but comes down to x to the power of 16x to the power of 2. Now when 16x to the power of 2 is here, we bring the other placeholder down, and it's 0x again. Let's go. Okay, now we need to find something that multiplies to that again. So when we need to find this, it's plus 8x. Because if you multiply plus 8x to 2x minus 4, you get this. Oh, big mistake. We get negative. I had to take a little break because I was setting this up. Now let's get back at it. When we minus this, it is just 32. And when we write this, it is just 32 and then minus 20. And when that happens, we have to do it one last time. Plus 16. Now we multiply plus 16 to 2x minus 4. And what that gives us is 32x minus 64. Now, the remainder of this thing is 44, which brings us to the conclusion that this entire equation is this. 3x to the power of 4 plus 6x to the power of 3 plus 4x to the power of 2. Let's move this a little bit. Plus 8x plus 16 and then plus 44 over 2x minus 4. Now that is indeed how we solve this. End behavior. End behavior is very important because it tells you how your graph is going to look like. We can describe it like this. You look at exponent. If exponent is even, well, you already know it's even. Now look at the leading coefficient. If it's negative, it's negative. So in this case, it's negative even, right? Here we have even. Is it even? Yes. Is it negative? No. So it's positive even. Now we look at this big boy over here. We have x minus 2 to the power of 4. What does that give us? Well, we need to see. 4 plus this exponent here that we don't see. It's 1. We come back. This invisible man. 1 exponent plus 4 exponent is 5 exponent. That is odd, right? Do we have a negative leading coefficient? No, we do not. So it is positive odd. Let's look at this one. We have a negative leading coefficient with negative. And this here, it is evidently 2. So I guess you could say 2 plus 3, because this is invisible, 3 odd. negative odd. Now here you look, 5 plus 2 plus 1, 5, 6, 7, 8, even, negative even. Here you look at it, you see this one, well, you have 1 plus 2, 3, 3 plus 5, obviously I don't know, 5, 6, 7, 8, you have 8, and it is positive. So positive even. There we go. All right, now what these look like is like this. So positive odd looks like this, negative odd looks like this, positive even looks like this, like up, and then negative even looks like down, and then negative even down again, positive even up again. Okay, now let's start writing this. So negative even is okay, negative even. Let's go to positive odd first because I remember it in order. So positive odd, positive, we have positive, we have negative to negative infinity. So as positive infinity goes to positive infinity, negative infinity goes to negative infinity. And now you go to the negative odd, which is just the infinity to, I believe, negative infinity to infinity. Yeah, I will double check. I will be right back. Alright, I'm back, and I did in fact error check them, and they are correct. Alright, let's get to the next one. We have negative even, we have negative even, so it's infinity, and then infinity, because as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to infinity. Now, the same goes for this negative even as well, this infinity, and this one would go to infinity, and then it would go to, I actually made a major mistake on this one. It is negative infinity, so infinity, negative infinity, negative infinity, negative infinity, and then infinity, negative infinity, infinity, negative infinity, negative infinity, negative infinity, and then for positive even it is infinity, infinity, negative infinity, infinity. So I believe that the biggest mistake I made is that I categorized negative even as having positives, but it didn't, because that's positive even, not negative even. Negative even has all negatives but one positive. All right, let's go to the next one, which is graphing the functions. Let's go crazy mode, ballistic, absolutely demon mode. All right, let's start plugging these in. Negative b over 2a. We have our 4 over, and then what is this? 2a, which is negative 1, 2 times negative 1. So you already know it's negative 2. Our first is negative 2, so that is our asymptote, or sorry, not asymptote, but AOS as, what is it? Axis of symmetry. Yeah, that's what it is. So 5 minus, what is our other number? Yeah, b squared. So negative 4 to the power of 2 over 4 times negative 1. What that gives us is, well, you already know, it's 16 over negative 4 times, and it's 5. So what this gives us here is negative positive. Yeah, that's a 4, negative 4, negative 4. Okay, yeah, that gives us positive, and that's just 9. So negative 2 and 9. Let's error check this. I'll be right back. I am in fact correct. All right, let's go on to finding the x-intercepts, or x values. Sorry, yeah, x-intercepts. Negative, you already know, x squared plus 4x minus 5. Let's get it. All right, x, you already know, plus 5. Yeah, plus 5. And then x minus 1. Yeah, that's about right. Okay, so our values would be -5 and 1. -5 and 1. You already know we got -5, and we got 1. All right. Our y-intercept is actually just 5 up here, and we don't have any multiplicities, which is great. Our center is here, -2 and 9. All right, let's start graphing this. We already know this is a negative even, so it's going this way, down, down. So we're going to drag this up to our vertex. Oh, that's a bit crooked, isn't it? No multiplicities, just straight down. These are the points that it intercepts. Alrighty, next one. This one is already in vertex form, as you can see. So we have our a, which is a 1 over, okay. What we need to find here, I believe, is our y. So yeah, we got to plug in 0. So it would be like 16 times 1 over 2, which is just, you already know, it's 8. 8 times 2, 16, minus 2, which is just, you already know, 6. Alright, so that's our y-intercept, which is 6. Here, there we go. Alright, now we have our x-intercepts, which is, actually we don't have our x-intercepts. We have our vertex. Our vertex is 4 and -2. Let's graph that right now. 4 and -2. We got it down here, right? And what we got to do now is find the x-intercepts. Let's get it. Alright, I have understood how to find the x-intercepts. Let me move all of this way down here, and let's start graphing, or let's start solving rather. Alright, let's get this. So we're going to bring 2 to the other side. 1 over x minus 4 to the power of 2 minus 2. So let's just go to the other side. It would be equal to 2. Alright, now what we have to do is divide 1 over 2, right? So, oh, actually no, not really. We can combine. I think I can combine it, yeah. X minus 4 over 2 over 2 equals 2. There we go. And now 2 times 2, 2. So this goes out, and that turns into 4. So what happens is, when this gets x'd out, -4 to the power of 2 equals 4. Right? And what that gives us is, well, this turned to the power of 2. And when that turns to the power of 2, this is going to be, I mean, you don't need to FOIL this, don't you? You don't need to FOIL this, because you could just be like, okay, x, you could do this. Here, let me show it to you guys rather than just blabbering. X minus 4, right? And then you could square root it out. So square root. And what that would give you is a plus or minus square root 4, because you square root it to get rid of the 2. So now it's just okay. Here, let me solve it. So x minus 4 equals plus or minus 2. And what that gives you, so when you bring x, it's just x equals plus or minus 2 minus 4. That's just x is 6 and 2. That's what it gives you. 6 and 2. This is a wacky one. This is obviously positive even. Wow. So that was a wacky one. But yeah, I think a good example to solve right now, because we're approaching the 40-minute mark, is the factoring questions. Now, I think that there are two very important ones on this list that I'd like to solve for you guys. So let's get it started. So first is the most basic. It is the 3x to the power of 4 plus this one. So first, what you got to do is evidently guess and check. That is what I would do, because it's frankly easy. So let's get it. We have 3x to the power of 4. Actually, no, never mind. You could factor by grouping this thing. You could just be like 3x to the power of 2. Yeah, you could factor by grouping this thing. 1x, which is just x, plus 6x minus 2. But that's like butchered. I don't know, man. You could still go this way though. So what you would do is you would just factor this as just 3. Wait, actually no. 3x to the power of 2, x to the power of 2. Wait, this is a bit of a dilemma. I wonder. We need to distribute this, which is already distributed. What? Bro, someone's car alarm just went off. What? That's crazy. I'll just do 3u, u, which is not u. I mean, because you could write it however you want there. And then you can do 6x minus 2. Wait, no, that doesn't make sense. If I were to guess and check this, I'll just do 3u minus 1 u plus 2. I know that's not like a good solve for it, but you could just replace it then, because you could just be like x, and then you could put in the missing dots. So this would just be to the power of 2, and this would just be to the power of... I know it's a really lackluster way of explaining it, but if you just plug in like the beginning coefficient of this 3, and then just place like x to the power of 2, so just factoring, like factor by grouping it, you could just factor this out. So it'd just be 3x minus 1, and then add the 2 later, and then add that 2, and then that would just be the answer. I don't know, man. That's pretty bad example. But here is the harder one, which is mostly z's and y's. So D. Alright, let's start with D. So first we gotta set our stuff straight. We gotta factor stuff out. YZ x to the power of 4 minus 13 x to the power of yz. Okay, we don't need to do any of this, because we can just factor this by yz. So yz plus yz, and then negative 13x to the power of 2, and plus yz 36. You just factor it out. So what that just gives you is all of this to deal with. You could combine these two. You could be like x to the power of 4 minus 13x squared, and then parentheses it, and then yz, and then plus yz 36. And what that would give you is essentially just combining all of it. So you just do plus 16, right? And what that gives you is a lot of numbers. Wow, so many numbers. Too bad I'm not reading them. Alright. Let's rewrite x to the power of 2, x to the power of 4 as x to the power of 2, and we'll distribute it later. So, this is a goofy question. Very, very goofy. Actually, no, this is 36, my bad. Where did it go? Wow, I made a goofy mistake. So 32. Oops. 32. Goofy mistake. Alright. Let's do x to the power of 2 minus 13x plus 36. And when you actually just guess and check this, it kind of just amounts to x to the power of 2 minus 9 x minus 4, because you redistributed the square that you took away. So putting this back, and then what that gives you is when you FOIL this, so when you FOIL this, x minus 9 is just x minus 9, x minus 3, and then x plus 3, and then when you FOIL x to the power of 2 minus 4, it's just x minus 2, and then x plus 2. And I think that's all answers, but it's yz because you already factored out yz. That's the answer to that one. That was a goofy question. I think that will be all that I will be solving because I'm approaching the 40-minute mark. I'm at the 40-minute mark. Thank you for listening in. I will cover more of this very soon. All right, bye-bye, and stay hungry for mathematics.